Hello, hopefully this works. I'm trying some new equipment here. Going over the homework for angle bisectors and angle addition postulate problems. Some of these are hard. So I'm going to skip number 1 because there's an example like that you should be able to do. And I'm going to do number 2, which is similar to 1. So if you watch 2, you should be able to do 1. Okay, so 2 says if the measure of PSR equals 77 degrees. So I'm just going to highlight PSR. Okay, so this is a hole right here. So this is a hole. And measure PSQ is 3y minus 7 PSQ. Okay, so this is a part. And then QSR equals 9y plus 12. QSR. All right, so actually number 1 is different because this actually gives me 2 parts and a whole versus this is part. But just to remind you, these 2 should be equal, and that's how you can start that one. Now the next one, it's just asking, is SQ, this ray, if this information is true, is that the bisector of the whole angle of the whole? Explain. So we want to know, okay, are those 2, that green and that blue angle, congruent? Then we would know it bisects. Okay, so, I mean, right now, we don't know the measure, like the degree measure of those. So let's go on a mission and find that out. Because we know if they're the same, then it's a bisector. If they're different, then it's not. So what we can do is set up an angle addition postulate problem and do part plus part equals whole. So I know that 3y minus 7 plus 9y plus 12 will equal the whole of 77 degrees. And let's figure out the value of y that would make this true, because that's going to be the only value of y possible. If you did, assumed that these 2 are equal, you can't do that. You don't know. You can't set these equal to each other and solve for y. You're going to get a value of y, but it's not going to be in such a way that this plus this equals 77. Okay, so if I continue on my journey here, this is 12y plus 5 is equal to 77. So 12y equals 72. And y is equal to 6. Okay, so that's the value of y. But I want to know, is SQ a bisector? The question is, does the measurement of PSQ, the green, is that equivalent to the measurement of QSR, measurement of angle QSR? Okay, so PSQ is 3y minus 7. Is that equal to 9y plus 12 for our value of y? So we'll plug in, or substitute 6. Minus 7, is that equal to 9 substituted in 6? Ooh, that already looks off. So this is 18 minus 7, this is 11, this is still a question mark. That does not equal, what is this, 66? No. 11 degrees, which is PSQ, given the statement in the directions, is not equal to 66 degrees. That is not an angle bisector. No way, no how. Oh, I can write over it. Cool, I can write in that black there. Okay, so that's how I would check. Okay, let's move on to 3 and 4. All right, so if you didn't get that, feel free to pause, go back, do whatever. Okay, so the measure of angle 3 is 6x. And measure of KAT is 90 minus x. 90 minus x. Oh, but I didn't read some information up top. AL bisects KAT. So here's AL. Oh, it's a bisector. So that means this AL, KAT is congruent to that. Okay, so this one, wait, did I read that wrong? AL bisects KAT, measure of angle 3 is 6x. Oh, when I drew 90 minus x, that's this whole thing. right? This is a whole, right, here to here, and then this is just a part, 6x. So really I should have drawn this in like blue or something. I know these two things are congruent, but the 90x is for the whole thing. This is 90 minus x. I don't know what this is right now. This is 6x. So ideally, I would want to do part plus part here equals whole and set up an equation. But I have to make a conclusion, and that's, what is this part? What is this question mark? And actually, I know it. Because it's a bisector, they're congruent, and this is 6x. So I actually can think that the two parts that I have, the 6x, the other part is congruent. It's the same. It's also 6x will equal the whole 90 minus x. Right? This is 6x. This is also 6x because they're congruent. Add them together, it'll equal the whole thing, which is 90 minus x. All right, so 12x, 11x equals 90. You don't get a pretty answer, but x equals 90 over 11. Okay, so the next one, you forget all the information in 3. 4 is a separate problem. The only thing that we continue to 3 is that AL is a bisector. All right, so let's clear our space here. We're going to do number 4. So it's still a bisector, so 2 is still congruent to angle 3. And now it's saying the measure of angle 2 can be represented by the expression x plus 12. And the measure of angle 3 can be represented by 6x minus 20. Okay, so this one is the one that's like number 1. I have an angle bisector, I have 2 congruent angles. Yeah, I have a part and a part. I'm not given the whole. So angle addition postulate, it's not a good strategy here. But the fact that these two things are equal are. Right? It's easy. Once I do x plus 12 is equal to 6x minus 20, I get 5x is equal to 32, and x is equal to 32 fifths. And that's all I have to do. The goal in the directions is just find the value of x. I don't need to find any angle measures, in degrees or anything. Okay. I wonder how long this video is right now. Hopefully not too long. The back page. Oh, I guess we redrew the diagram here. So same diagram, different info. Measure of angle 1. So this is still a bisector. So let me just mark that that's a bisector. These two things are congruent. Their measurements should be equal. So the measure of angle 1 is 7x plus 3. The measure of angle 2 is 6x plus 7. Okay. And then the measure of angle SAT. Now notice, SAT, this is the whole, is 10x plus 67. So we're trying to set up some algebraic equation. Now this time we're given the whole, and we're given 2 parts. We're given 1, we're given angle 2. Now this hints, what do we know about the measure of angle 2 and 3? Well, I know they're congruent. So if measure of angle 2 is represented by 6x plus 7, you know what? The measure of angle 3 we can say is 6x plus 7. Right, so here's part 1, here's a part, and then here's my other part. And I can do, for angle addition postulate, part plus part plus part equals the whole. So we're going to do 7x plus 3 plus 6x plus 7. Here's part 1. Here's the second part, which is congruent to the third part, which is exactly the same, is equal to 10x plus 67. What do we need to do? Just find x? Okay, so now this is a pretty straightforward equation. If you simplify, combine like terms, I'm going to skip this part. You should get 9x equals 50, and that x is equal to 50 divided by 9. So this one's just a little different than what we did in class because you had another part that they didn't explicitly give you, but you could figure out because you know what's congruent, you know which measurements are equal. Okay, let's do number 6. Last one. All right, OT is the bisector of ETM. So immediately I hear bisector and I think, all right, I got congruent angles. So I locate OT, right? That's the bisector of ETM. Okay, so I know that angle 3 and angle 2 are congruent. Bye, Andrew. Recording a video. My voice is being recorded. Goodbye. Okay, sorry, everyone. Okay, where am I? Sorry. All right. They give me angle 1. They give me angle 2. So, like I know in the last problem, I could also say the measure of angle 3, they don't give me that, can be represented by 3x plus 6. That's the same, because they're congruent. Find the value of x and the measures of all of the angles. So I know all the parts, right? I have this part, 6x minus 12. I have this part, 3x plus 6. I have this part, 3x plus 6. And I want to do part plus part plus part equals whole. But what is this whole? It's from here to here. It's a semicircle, that angle GTM. So if I add up all the parts, they're going to equal 180 degrees. So this is another one. We're just trying to do angle addition postulate. Part plus part plus part equals whole. Or part plus part equals whole, whatever you want to do. And they just didn't give you the whole, but we can figure it out because the whole is a straight line. It's 180 degrees. All right, so now we'll put it all together. I have 6x minus 12. That's the angle 1. And then I have 3x plus 6 twice. And now you can add it twice, or you can just double it. Like you could have multiplied it by 2. So there's the 3 parts will equal the whole 180 degrees. Combine like terms. Things are actually going to cancel. I get 12x equals 180. So x is equal to 15. Cool. So I found x. That's one of the goals done. But now I need the measures of all the angles. All right, so if I want the measure of, maybe I'll go along this side here. The measure of angle 1, usually represented as 6x minus 12, right? 6x minus 12. So 6x is 15 minus 12, and that is 78 degrees. Cool. Measure of angle 2. Usually 3x plus 6 if I input 15. So 45 plus 6, that's 51 degrees. Notice I'm putting degree symbols because these are measurements of angles. So we measure in degrees. And lastly, the measure of angle 3. Oh, well, it's congruent, right? This diagram got so messy. 2 and 3 are congruent. So I don't have to do any math. That's also 51 degrees. And you can check your work. 51 plus 51 is 102 plus 78, 180. Great. Hopefully all my sound got to the computer because I've been talking to the board a little bit. All right, I'm in 110 in the geometry room doing this. All right, let's figure out if I can stop it. Hope this video worked. And how do we end it? Was it recording?